Okay, going over a few examples of vectors. We still need to talk about a couple of new terms as well, but we'll run through some examples. So if you look at the examples, it says name the vector and write its component form. So be familiar with all the forms on how you could write a translation. One is vector form, one is component form, and then the last way is ordered pair notation. So to name the vector, again, you always have to start with, this is the initial point on number 1, M. N is the terminal point, and then you just have the little vector symbol right above it. So the vector symbol, again, it's like half a ray on top there, not a full arrow. Would not be correct if I did write a full arrow. And then to figure out the component form, again, component form looks like this. I'm already planning ahead, even though I didn't put anything in yet, but it's your brackets. So the horizontal component is written first. That's right here, and it's 4 units to the right. So the horizontal component is 4, and then the vertical component, if you're counting along with me, 1, 2, 3, 4, 5, 6, 4, 6. Maybe take a minute, pause, see if you can write the vector, naming it on number 2, and then component form. So the vector in this case is vector BA. That's the name. B is the initial point. A is the terminal point. And then to write it in component form, here's the horizontal component. You start at point B. That's the initial point. Initial means starting point. And then terminal point is the ending point. So it's 1, 2, 3, 4, 5 units to the left. So the horizontal component in component form should be -5, and then it's 1 down. So -5 and -1 for the component form. Okay, and then my next example here, it says the vertices of triangle ABC are 1, 2, 5, 1, and 5, 4. You want to translate triangle ABC using the given vector, graph triangle ABC and its image. So I made this problem a little bit easier. If you noticed on the graph that was given, everything was going by 2s. Sometimes people get a little bit confused and then just count by 1s on the graph. So if there's no units on the graph, like I don't have any units here, then you're going by 1s. On the last one, if you use that, unless you change the units, then everything was going by 2s. Okay, but I'm going to look at problem number 5. It was, here's the component form, -2, -4. This is your translation. So what that means is in this triangle, triangle ABC, I could write it like this, little symbol, triangle here, triangle ABC. Every single point would translate, in this case, 2 spaces to the left and then 4 spaces down. Easiest thing to do is just translate each of the vertices. So I translate A, 2 spaces to the left and then 4 spaces down. Same thing with point C, 2 spaces to the left, 4 spaces down, and then point B, 2 spaces to the left, 4 spaces down. Okay. And then when I label that triangle, first of all, we've talked about congruent segments. We've talked about like congruent angles as well. We could also have congruent polygons. This translated polygon or triangle should be congruent with this, which means all the sides are congruent and then all the angles are congruent. If you come up with a congruent figure after a transformation, doesn't matter if it's a translation, rotation, anything else, that's what's called a rigid motion. So a translation, as you see, even though this is only one example, is a rigid motion. Any type of transformation that produces a congruent figure.
Good morning.
Okay, so this figure is congruent with this figure. To name it, we went from point A, that's the pre-image right here. This would be the image, so we use prime notation. A prime, this is the translated point B, or this is the image, this is the pre-image, so this would be B prime, and then this point right here is C prime. Be able to write all the coordinates as well, like A prime would have the coordinates, and we're talking about the ordered pair coordinates, so it wouldn't look like this. It wouldn't look like component form, so these are actually supposed to be parentheses. These are not, but the coordinates of A prime, since it's -2, -4, 2 units to the left, and then 4 units down would be -1, -2, and so on. B prime would have the coordinates 3, -3, and then C prime would have the coordinates 3, 0. So if you can translate a figure, now it's just a matter of all the different notation, using prime notation, component form, vector form, ordered pair notation. Okay, there's possibly a lot of new notation if you didn't learn this before.